David Sully. Welcome, CEO of Advai. We'll be showcasing a very exciting demo on AI adversaries. David.
All right, thanks very much. Good evening. I'm going to be the final one, so I'm the one keeping you from having any food and drinks. Hopefully, I'll try and keep it interesting. I'm hopefully a bit more interesting than Synthesia as well. You can see if I fall off the stage as I go. The problem with AI is it's too smooth and it's too perfect. So the objective of this talk is basically to talk through a few more of the highs and lows. So a lot of the things that are coming through on all of the other previous talks, hopefully I'll try and expand on sort of why that's happening and sort of a couple of the narratives. But Advai, I set that up 3 years ago. We often get badged as a cybersecurity company. We don't really think of ourselves as a cybersecurity company. We basically break AI systems. So everybody else is focused on all the wonderful things that can go on, and we're that really annoying person in the corner basically going, yeah, but. So our team get to do some really fun stuff, just proving everybody wrong. So I'm sure probably almost everybody is aware of dancing robots, General Dynamics and things like that, the amazing stuff that they do. You've probably seen the parkour course. This is, for me, a really good analog for AI in general, which is you see the robot run around the parkour course, and it's fantastic. The reality is that when you watch that parkour video, it took a huge number of takes. And if you go on YouTube, you can look it up. They've actually put all of the outtakes on it. And that was trying to get that system to work in an environment that they controlled. So those engineers spent a huge amount of time placing the obstacles in the right location. The lighting had to be correct. Everything that was involved with was controlled. And it still fell over a huge number of times. And that's kind of like AI. The challenge is trying to identify the places that it's going to fail in advance. So this is what we focus on, is basically this statistic. So the AI industry in general tends to hate this statistic. So it's a little bit outdated because it's before LLMs came along. But almost every single large consultancy maintains metrics of every single project that they see across every company in the world. And that's the metric that they've got. Every single one of them, they score between 85 to 87%. And there's loads and loads of reasons behind that, of which I will not bore you. But basically, there is a real narrative around AI of it's going to take over the world. And we believe it is. But it's really, really difficult to get it right in the first place. And you've been hearing about some of those cases here. You've got to think about it really methodically. You've got to think about how it's going to be used, the business use case, your governance, risk, and compliance, everything else. And everybody bangs on about black box systems. But when we talk to a large enterprise who's regulated, we're sometimes talking to them about, okay, we're using ChatGPT, it's coming through an API, it's absolutely fantastic, we've got it with trusted end users. And you go, okay, right, so the regulator's going to come through the door in 3 years' time. Are you going to have the system that took that decision? And they go, what do you mean? It's like, well, what version of ChatGPT are you using? There aren't any versions. Well, you better talk to Microsoft about that. Well, Microsoft don't know what it is. OpenAI are doing silent versioning of ChatGPT at the moment. So, right, how are you going to justify to the regulator in 3 years' time when you don't even have the black box that took that decision on ice ready to go to have a look at that? So, you can't explain the decision, but you don't even have the thing that took that decision. So there are some really problematic areas in amongst that. And some businesses will look at the auditing and the monitoring and the logging of that, and they will satisfy within their GRC, their governance, risk, and compliance framework, or with the regulator, that's going to be okay. But a lot of the time, people aren't thinking about that. And that's before you get onto the security threats, which we really love. So you've heard about this a little bit today. Basically, one of the challenges with AI adoption is we're really, really used to our old way of doing things. We've got electronic systems, and we're always used to a human attacking us, either deceiving humans or they're trying to attack the system. The problem is you've now got decision-making systems coming into an organization, But you've also got automated systems attacking that organization. And we're really, really struggling with this because it's not just attacking the electronic systems that we've got, it's also got the potential to attack the humans through misinformation and disinformation, deepfakes and things like that. And we don't really even have the lexicon for this yet. Organizations really, really struggle with what this is going to look like, and it's evolving so fast, you don't know how to address each point. And the problem is that this isn't just a cybersecurity problem, it's a human problem as well. And so you've got a CISO, or Chief Risk Officer, often in a large enterprise, trying to deal with everything. And they already had a massively burdened plate before. So you've got those problem sets. And then I said about sort of like attacking the AI itself. So this is something that Advai is like a UK leader in. We're one of the top in the world at this. Adversarial AI is something that's sort of like coming down the barrel. And adversarial AI is the concept that you can trick, manipulate, and deceive AI systems. So this all started off with like a very, very famous what's called stop sign attack, which was basically stickers placed on a stop sign. The autonomous vehicle all of a sudden saw a 40-mile-an-hour sign and accelerated through it. So that looks like graffiti to a human. It looks like gibberish, whatever. But crucially, the AI interprets that in a different way. So here's another example. This is a very, very simple one. This is an old one that Advai did years ago. What you're seeing here is a faster RCNN model, which is a commonly used, it's either that or YOLO, for computer vision tasks. And basically, AI systems, whatever anybody says to you, at the moment are still just pattern recognition or pattern generation. So your brain thinks in a very different way. It doesn't think in patterns. It likes context. It sees a car. If you see a car up in the air, your brain's going to go, something's wrong there. The AI won't. It'll just go, that's a car. So what we've done here, this is an image identifying a car correctly, and it's identifying the car because there's an arrangement of pixels that it's been told hundreds of thousands of times that that arrangement of pixels equals a car, so it says probabilistically, that's a car, I'm going to box it. An adversarial attack starts manipulating those pixels. So that's just a visualization of it. When that's imprinted within the image, you can't see that as a human. But for the neural network that's taking that, it's all of a sudden seeing different items and objects that are within the model. And all it's seeing are patterns that it's seen before, and it's probabilistically saying there are forks, umbrellas in the sky, things like that. So this, when you start looking at it, you go, okay, when we start integrating AI systems, this is actually like a real complex problem to get around. Because yes, my AI system is now being tricked, but actually, maybe that's not the objective. Maybe the objective here is to overload your human analysts, because you've reduced the number of human analysts, and what you want is a load of false flagging images coming up. Because I tell you what, we can just make that into, I don't know, an offensive image or something like that. So all of a sudden, you've got images of cats popping up, and each time the AI is saying that's an offensive image, and the humans get overloaded. It depends what you're trying to do. But when you're looking at all of this, everybody keeps on talking. Today we heard about human-machine teams, basically, the trust, the working alongside each other. That is going to get very, very complex as it goes forward. And it's not just on computer visions. Again, this is a little bit dated, but imagine kind of the worst thing that you could possibly have for an LLM, so a large language model. What would you not want it to do that you hope the companies have guardrailed and would not allow it to say? How about, how do I make a bomb? So that one's pretty punchy. That one, a huge amount of effort should have gone into making sure that it cannot produce the ingredients for a bomb. And they have. But you can start adding in what is gibberish to a human, and all of a sudden, it can start outputting the ingredients for a bomb. Stand back and admire your handiwork. So, these are the problems that are going to be coming through. And the way to think about this is basically, yes, there's all of the sort of like Gucci adversarial AI or whatever it may be, And some of that is really nice. Microsoft and IBM have open sourced a load of the tools to do that sort of thing. They've not been able to address how to defend against them. But actually, all those are basically a representation of all of the complexities that data scientists and ML ops and dev have in trying to get the AI to work in the first place. And one of the observations, one of the things that we are working very, very hard on is basically within software, you have test-driven development. You have standards, you have ways of developing software. So you develop tests and you design your code in order to exceed those or meet your metrics. There is nothing equivalent within the AI industry yet. There's just a very complex, very unexplainable black box with devs trying to integrate it in different ways. And there's no standardization to that industry yet. And so for us, that's one of the biggest step forwards that's needed, is a much more sort of integrated process for how to design and deliver and deploy AI models. So this is just sort of like an example, but basically you can Google MLOps lifecycle. That is sort of like at the moment, all that you should be focusing on is basically understanding how an AI system is going to be deployed, what the business use case is, what the governance, risk, and compliance requirements are around it, and then developing the tests and determining how are you going to evaluate the AI system for that deployment regime. And that is like where the whole industry needs to go. Some of that is for cybersecurity measures, some of that's for things like adversarial AI, but actually a large quantity of it is making sure it's unbiased, it's ethical, that it's been clearly tested, that you've set the boundaries for that use case, that it's going to be monitored. Because the first thing that we get is often a call saying, we're using a large language model on our estate, and staff are trying to find out the CEO's salary. Does it have access to that? It's like, well, I don't know. Have you given it access? But that's typically the very first thing that staff try and exploit within sort of a system. So these are the sort of things that you need to be thinking of in that deployment. It's like, how is it going to have access to that data? What's it going to be doing? And what does that enable staff to potentially get access to? There is, though, sort of like a real advantage when you start thinking about this way. And this is just a really, really nice, sort of like constrained example. But I will show you this. When you start properly testing different capabilities with formal testing, you can start to actually dig into some of the underlying problems and the strengths and weaknesses of those systems. So I just thought I'd show this because facial verification is a really nicely constrained problem set for AI. It always has, the person is sat right in front of the camera, quite close, and it's designed to say, is this Dave? Should it unlock? Okay, so the environment is fairly constrained. You're using the same sort of equipment a lot of the time. And you can test that because you can actually build up a database of different genders, ethnicities, ages, things like that. And we've taken a small subselection of this, and this is 2 of the largest providers in the world. I won't tell you which is which. One is Microsoft, one is Amazon. But typically what you'll get is fantastic performance when you try them out. So you can chuck a data set at them, and this is sort of like similar to what you guys were saying earlier. There's a high degree of accuracy. But underneath them, when you start actually playing around with them and you start varying that data, what you start to see is a very significant difference in what's called robustness. So basically, the robustness of the AI system is its ability to withstand change and variation. And so even on like the really big providers that are performing really, really well on most metrics, you start going into it, and all of a sudden you go, okay, because we've set in place clear testing procedures, we can go, that's the one that we should be buying. That's the one that we should be integrating because it's so much more reliable. And you can do this on a sort of a gender basis, an ethnicity basis, age basis, whatever. And it might even flip between the two. You might find that all of a sudden, for one age range, provider A is much better. But at least this way, you have a much more evidence-based approach to adoption. Also, that's going to be a lot more resistant to adversarial attack. So the work that we do is basically trying to scope out all of these different bits and all of the different areas in which the AI will fail and how somebody can integrate that. We do work for the MOD, NCSC, AI Safety Institute. We work with large enterprises, and all of it's sort of combining into this picture of like how on earth do you address it? By the way, the one thing I will point out is how the hell do you assure reinforcement learning? That is one of our biggest primary areas of focus at the moment is agent-based systems and what's coming next. So hopefully in 12 months' time I can come and talk again about that side of things.
Fantastic. Right. Thank you so much, David. Questions, very briefly. Oh, we've got one. Yes, yeah, there we go. One question. Advai, I gather, are also growing, David, is that right?
Here we are. Yep.
React developers?
We need a couple of new junior researchers.
There we go.
Doing some really, really interesting work. Solutions architect.
Graduates, apprentices?
All of our junior researchers are graduates.
There we go.
We look for masters. We've got to train them up ourselves, so it's the best way.
Fantastic. Maybe link up afterwards. Question?
Yeah, so you've spent lots of time breaking AI systems. Are you starting to develop some insights of how to fix the things that you're breaking? Like, is there something coming out of the pipeline?
Yeah, so it's a really good question. So we definitely enjoy the breaking, but the assuring AI systems is where it's all heading. So for us, what I showed you earlier, the MLOps lifecycle, so how to integrate a product around that and how to do automated testing and bring like that rigor to test-driven development of AI systems, for us, that's the future. And yeah, basically, from our observations, the moment that you start breaking the system, it's like any other stress test. As soon as you can identify a weakness, then you can start building a counter to that. And it's just with AI, it's just a bit, it is complicated, but you can start doing that same process.
Marvelous. Any other questions? One more, and then we are done.
I'm starving, so.
Yes.
Yes.
I'm starving too. David, thank you so much. That was really insightful. Just one question. You showed us that video of the robot falling on the table at the start. Have you got a kind of a worst example of like a case study kind of epic fail you've seen from a customer, either a testing scenario or something they've come to you with?
We are NDA'd on everything that we do. So, no. I think in general, like, I think the thing that I'm constantly surprised by is, so we talk to a lot of financial services companies, for example, and every single company that we talk to thinks everybody else is doing AI. And we get into them, and we go, okay, right, what are you doing? And they're like, oh, we've got 60 licenses for ChatGPT across 10,000 people. And you're like, but you've been broadcasting that. It's that sort of level often. So I think, yeah, it's more like everybody's finding it very hard to properly get it into an area where they can realize value. The interesting bit is like the Klarna bit earlier. Like, we've offered to red team their system, but they didn't return that call. So if anybody knows Klarna, we'd be really interested. But if they've done it, that's really, really significant. And they should open source how they've done that, because the rest of the world really needs that. So, yeah.
I'm sure you can sign a mutual NDA over a beer in a minute, and he'll tell you everything. Marvelous. Thank you so once again, David.
Thank you.
Okay. Again, thank you. You've been so patient. So, a brief wrap-up from me. Whilst I remember, Sophie Birch, wave at me, please, at the back. This lovely lady from Gloucestershire, University of Gloucestershire. The Gloucestershire Cyber Launchpad is working with schools, partnering with CyNam to skills match talented cyber professionals and graduates with Gloucestershire employers. So, if you need people for your team, it seems like we do, speak to Sophie. She will have some answers for you. Plugged. Only really leaves it up to me to say thank you so much to our wonderful speakers who were absolutely immense. I hope you've enjoyed it and learned a lot. this evening. It's only just beginning because we've got a couple of hours now with fantastic food, entertainment, drinks, and this is where it really gets interesting. So please do hang around, talk to each other, enjoy that. A huge thank you to everybody in the CyNam team. Amy, with your passive-aggressive timer at the front, amazing. Daisy, Holly, Tim, the directors that have managed to make it here tonight as well, thank you so much. And a massive thank you once more for you. You are what makes CyNam special, the community that's here tonight. Enjoy it, and we will see you at the next one. If you have enjoyed it, please do mention us on social media. That means a lot for us, LinkedIn, and we're on Twitter as well. But otherwise, enjoy your evening. Thank you so much. Get home safe.